Today, I will talk about how to use a graphing calculator to decide which regression equation is the best fit. First of all, we clear the memory. Second plus 712. We are given this data and to check which one is the best fit. Therefore, we go to Stat, Edit, we put Enter. L1 will be year, so we got 0, 1, 2, 3, 4. Then go to L2, you put in 38000, enter. 39140, enter. Then we got 40314, enter. 41524, enter. 42769, enter. Since we need to compare those two regression equations, we need to put the second 0. Make sure the diagnostic on. So I move the arrow to that diagnostic on. Here you go. You find that diagnostic on. So I put the enter. This one will show you which is the best fit when you have two regression equations. Therefore, let's go to second Y. You will put plot 1 on. So I put the enter. You don't have to change anything for this part. Then you need to set up the window. We go to zoom, then go to 9. That's zoom stat. I press enter. So you could see this is the data shown on that window. Next step, we need to figure out these two regression equations. One is linear, the other is exponential, so that you can compare. Go to Stat, go to Calculate. I need a linear regression. Let's go to 4. So I press 4. Put the enter, because that's really L1, L2. Just forget about this frag list. Go to Store Regression Equation. That's Y1. So I go to Variable. Y variable. Enter. That's Y1. That means we restore this regression equation in Y1. Then I put the enter. You got the R squared, that's 0.9996. R equals 0.999847. Now that we have R and R squared, let's talk about what they mean. The R value is what is known as a correlation coefficient. It's a number to tell how well the straight line fits the data. The closer the R value is to +1 or -1, the better the line fits the data. As the R value gets closer to 0, the worse the fit gets. The R square value is found just by squaring the R value. In statistics, the R square value describes how much of the variation in the data is accounted for by the trend line. Then I go to stat again. I need to check that exponential regression equation. So I go down, find out that exponential regression. I put enter. Still L1, L2, no problem. I need to restore this regression equation, go to Y2. So go to variable, Y variable. This time I want to store this equation into Y2. So enter, enter, enter. Then this time you compare the R. The R we call correlation coefficient. Which one is closer to 1 will be the best fit. Now we already know the meaning of R squared and R. Just compare this exponential regression equation and linear regression equation. We know for exponential regression equation, this R greater than this linear one. Therefore, exponential regression is the best fit. You can go to graph to check. See, it's not clear. We go to Y1. This is Y1, here is Y2. Y1 will be linear and then Y2 will be exponential form. I will change Y2 into this one. Enter. See, look at this part. Then I graph. That's almost the same, but compared to that R, we know exponential will be the best fit. Therefore, answer will be C. Exponential regression and increasing by 3% each year, because we got over here B equals 1.03. That means increase 3% each year. Now I will show you use the best fit regression equation to figure out the following two questions. Question 1. Use the best fit regression equation to find out the yearly salary in dollars in 15 years. There are two ways to do that. First of all, we already know we store regression equation in Y2. Therefore, check. This is a Y2. That's the regression equation. Therefore, I can do variable, find the Y2 first. Y2. Then I put the parentheses, here's 15. Then put the enter. That's your answer. The second method is we already got this regression equation. And you can just like plug in x equals 15 into this equation. Then you can get the answer. Let's try 38,000.02179 times parentheses 1.024912349 and then 315. We do 15th power. See, almost the same answer. Now let's go to question 2. Use the best fit regression equation, which means this exponential regression equation, to find out in how many years the employee's yearly salary is more than $18,000. First of all, since we restore this regression equation in Y2, we can go to second graph, check the table. Check this part, Y2, and that is 26 years. Then the yearly salary will be more than 18,000. Now I will show you how to use a graph to figure out the answer, specific answer. First of all, we go to Y equals. You have to change the window. For minimum window, we don't change the maximum window. We change into 50. And for minimum, you don't worry, and a maximum, we need more than 80,000. So I will do 85,000. Then I put for Y1, I clear. I don't need the Y1. We already know the Y2. I will put the Y1, that's 80,000. Then I go to graph. Then I do second trace, 5. Enter, enter, enter. Let's give you 25.185. This will be the answer. But in what year? Definitely that's 26 years.